Hi there, Mr. Sutton here, bringing you the AB Calculus 514 Extra Practice Number 3 solutions on integration by substitution with indefinite integrals. On this problem, trying to take the indefinite integral for this expression, one thing that might help us out is we have an inner function, something with an ln of x in it here, whose derivative, something with an x, is elsewhere in the problem. So let me start by letting u equal this inner function of 4 plus ln of 2x. And then we can write du equals, well, derivative of 4 is 0, derivative of ln of 2x, that's going to be 1 over 2x times 2, so 1 over x dx. And then multiplying here, we have x du equals dx. Going back and doing some substitution, we can write this as 5 times u cubed over x. And now instead of dx, we have x du. These x's are going to cancel, so that's just 5e to the third, or 5u to the third, rather. There's no e in there. But now we can use the reverse power rule. This bumps up to an exponent of 4. Dividing by that, we have 5 fourths u to the fourth power plus c. And then I'm just going to go ahead and substitute the stuff that u equals back in here into the expression, giving us our final answer. For this problem, I notice that I have an inner function, something with an ln of negative 3x, whose derivative, something with an x, is elsewhere in the problem. So there's really nothing else for it. I'm going to try substitution on this. If that doesn't work, we're pretty much out of luck. So let me do u equals negative 2 plus ln of negative 3x. And then I can write du equals the derivative of this, which, let's see here, negative 2's derivative is 0. Derivative of ln of negative 3x, that's negative 1 over 3x times a tail of negative 3. So those negative 3's actually cancel, leaving us with just 1 over x dx. So then we can say dx equals x du. Substituting back into the original, we have 2 over x times u cubed, and instead of dx, we now have x times du. These x's are going to cancel, so I can write this as just 2u to the negative third, and then a du is still in there. Using my reverse power rule now, this bumps up to a negative 2. Dividing by that, we have negative 1 u to the negative 2 power plus c. And I'll just replace the u with the stuff that u equals over here to get my final answer. On this problem, trying to take the antiderivative of this expression, one thing I notice is that I have an inner function, this 3 plus ln of 4x, whose derivative, something involving an x, is elsewhere in the problem. So let me start by doing some u substitution. I'm going to let u equal 3 plus ln of 4x. And then du, the derivative of that, is just going to be 1 over x, because this 3 is a constant, so it's a 0 when you take the derivative. And derivative of 4x, ln of 4x is 1 over 4x times 4, so the 4's cancel. We just end up with, again, with du equals 1 over x dx. So that means that dx really equals x times du. Okay, making some conversions over here, we can write this as negative e to the u power all over x times, this is now going to be x times du instead of dx. These x's conveniently cancel out. This is just negative e to the u du. And then antiderivative of that is just going to be negative e to the u plus c. And now I'll just replace u with 3 plus ln of 4x to get my final answer. Trying to take the antiderivative of this rational function, it's a little bit tricky because there's no way to really reduce this fraction at all. One thing we can do is kind of thinking of this 4x to the 5th plus 3 as an inner function. And if we think about it that way, we notice that the derivative of this denominator, something that should have an x to the 4th in it, is up here. So let's try some substitution on this one and see what happens. I'm going to let u equal 4x to the 5th plus 3. And then du, the derivative of that, is going to be 20x to the 4th dx. So then we have du over 20x to the 4th equaling dx. Substituting back in here, I can rewrite this as 20x to the 4th over u times, and now instead of dx we have du over 20x to the 4th. Well, those 20x to the 4ths actually cancel out perfectly. So this is just going to be 1 over u, or u to the negative 1 du. And now the antiderivative of 1 over u, that's just going to be ln absolute value of u plus c. As a final step, let me just replace u with 4x to the 5th plus 3, just substituting that back in. And there we have it. For this problem, really the only way to do it is with substitution. And I know substitution is the way to go because I have an inner function, 1 minus 4x cubed, whose derivative, something with an x squared, is elsewhere in the problem being multiplied. So let me start by letting u equal 1 minus 4x cubed. And I'll take the derivative of that, du, which equals negative 12x squared dx. Dividing by that, we end up with dx equals du over negative 12x squared. Substituting back in, this is now x squared times the square root of u times du over negative 12x squared. And then these x squareds are going to cancel. This is going to be negative 1 over 12, and I'll just write this as u to the 1/2 power. Now we just have a du in there as well. And this is just a reverse power rule problem now. Bumping this exponent up by 1, we have a new exponent of 3 over 2, which means I'm multiplying by 2/3. Well, let's see. Negative 1 over 12 times 2/3. That's going to be negative 2 over 36, which is going to be negative 1/18th. And we'll have u to the 3/2 there, plus c. Replacing u with the stuff that we let it equal in the beginning, we have negative 1 over 18, parentheses, 1 minus 4x cubed, all raised to the 3/2 power, plus c. On this problem, one way you might try doing this is expanding this x squared minus 4x plus 5 to the 3rd power, but that would involve taking 3 of these, multiplying them together, distributing that to the x minus 2, huge mess. Another way to do it, if you notice that we have an inner function, this quadratic, and its derivative is elsewhere in the problem, this linear function, we might try some substitution on this. Let's let u equal this x squared minus 4x plus 5 expression here. So then du equals 2x minus 4 dx, and we can write du over 2x minus 4 equals dx. Going back and substituting in the original, let's see what happens. I can now write u cubed times x minus 2, and instead of dx, I've got du over this expression. Now, this expression, you could, if you wanted to, factor out a 2, leaving us with, this is actually going to be 2 parentheses x minus 2, so you can cancel this x minus 2. This is going to just leave us with 1/2. If after you cancel that, that just leaves us with 1/2 u to the 3rd power du. So that works out pretty nicely. And then using our reverse power rule, this bumps up to a 4. Dividing by that, we've got 1 over 8 u to the 4th power plus c. And then we can substitute the u back in to get that quadratic to the 4th power, giving us our final answer. On this problem, the key is recognizing that we have an inner function, e to the 2x plus 2, whose derivative, something that also has an e to the 2x, is elsewhere in the problem. So let me start with some u substitution. I'll start by setting e to the 2x plus 2 equal to u, and then I can write the derivative of that, du equals 2e to the 2x, and that 2 there is gone. We do have a dx though. So now dividing, we have dx equals du over 2e to the 2x. Substituting back in, we can write negative 8e to the 2x times cosecant squared of u, and then instead of dx, we've got this du expression. It looks like the e to the 2x's are going to cancel out. We still have a negative 8 over 2, which is negative 4. We still have cosecant squared of u du. Taking the antiderivative of this, antiderivative of cosecant squared is negative cotan, but there's already a negative there, so now we have a positive 4 cotan of u plus c. And I'll just substitute that u stuff back in here for the u in the final expression to get my final answer. For this problem, this looks like a big mess. One thing you might pick up on, though, is we have this repeated inner function, 3x squared plus 2, and a little bit more than that, the derivative of that thing, something involving an x, is also in the problem. So let's try some u substitution here. I'll start by letting u equal 3x squared plus 2. And then du, the derivative of that, is just going to be 6x dx. So we can write du over 6x equals dx. Substituting back in, I'm going to rewrite this as negative 6x cosecant of u cotan of u. And instead of dx, we have du over 6x. So now the 6x's cancel completely. That leaves us with just negative cosecant of u cotan of u du. And the derivative of that is pretty much an exact match for our derivative cosecant of u plus c. So now plugging the u value back in, we can write cosecant of 3x squared plus 2, all of that plus c. On this problem, trying to take this antiderivative, I have this inner function, negative 1 plus ln of 2x, whose derivative, something with an x, is elsewhere in the problem. So let me try substituting on this one. Let's let u equal negative 1 plus ln of 2x. And then du, taking the derivative of all this, negative 1's a constant, so that becomes 0. Derivative of ln of 2x is going to be 1 over 2x times a tail of 2 using the chain rule. So that actually cancels the 2's and leaves us with just 1 over x dx. Then I can multiply by x to get x times du equals dx. And back over here, substituting back in, we can write 4 sine of u all over x. And then we have x du instead of dx. So these x's are going to cancel. That's just now 4 sine of u du inside my integral. And antiderivative of sine is going to be negative cosine. So this is negative 4 cosine of u plus c. And then substituting back in for the u value from what we did earlier, we end up with our final answer. In trying to do this problem and find this indefinite integral, it's going to be tough to solve this one by simplifying. But if you treat this denominator as kind of an inner function, you'll notice that its derivative, e to the 5x, or something with an e to the 5x, is elsewhere in the problem. So maybe we could try using a little u substitution to see what happens. Let's let u equal this denominator of e to the 5x minus 1. And then du is just going to be 5e to the 5x dx. Dividing by that, we have du over 5e to the 5x equals dx. And substituting back in, I can now write negative 10e to the 5x over u, and then we have du over 5e to the 5x. That actually works out pretty nicely. These e to the 5x's are gone. Negative 10 over 5 gives me negative 2, so I have negative 2 over u, or negative 2u to the negative 1, however you want to write that. This is really just going to be, if you take the antiderivative, negative 2 ln absolute value of u plus c. And then replacing u with e to the 5x minus 1, we can write the following, which gives us our final answer.